Hello everyone. In this clip, we are going to see a couple of forecasting techniques in time series analysis. For forecasting, we need to see whether the series has any of these, whether there is trend or if there is seasonality, cyclicality, or randomness. Let's take a series. It's crude oil imports in India. The plot shows imports month-wise for 2 years, and it can be seen that the series has not much of trend, but there seems to be some seasonality as evident from, you know, these lower values of imports around the month of September. And this is repeated in both the years. So there seems to be some sort of seasonality in this series. The same data is plotted over time for 24 months, and here you have September 2022, and here you have September 2023, and this suggests to some sort of seasonality. And if you have to focus the series, we need to take care of seasonal influence. So let's proceed. For this illustration, we are going to use method that corrects for seasonality, and for comparison, we also will use a method which uses trend in forecasting the series. So if you have to ignore the properties of the series and want to fit a trend and project, it can be done, but whether the forecast will be accurate or not will have to be questioned. So for comparison, we'll do trend projection first, and then we'll do projection with seasonal adjustment. Since we don't see any trend, we'll use seasonal adjustment without any trend. That's the third equation here. We'll use this seasonal adjustment. For comparison, we'll use trend projections. If there were trend in the series, maybe we would have been using this second one as well, but in this case, we are not using it because the series don't have a trend as such. So to forecast the series, we need to estimate these linear models. And once it is estimated, we will be able to do the forecast. An estimate shows that the trend equation is equal to ST equal 19,379 plus 6T. So that's the first equation here. And the third equation, which is estimated, that has the empirical parameter estimate of constant equal to 20,871, followed by seasonal dummy estimate, dummy for first month of the financial year, which is minus 60, followed by the other dummies, since there were 12 months in a year, we have put 11 dummies, and these are the estimate of the dummies. And the estimates will be shown in a while. Once you derive the estimate, it is possible to project the numbers or focus the numbers for the required month. It can be within the sample or outside the sample. And once estimated and forecasted, the accuracy also needs to be figured out. Now let's go to the Excel sheet and implement these two equations and thereafter forecast the values. So the series has 24 observations. Time is given here and the dummies are given here. For example, for April, the dummy one takes value 1, and for rest of the months, it takes value 0. Likewise, for the month of November, D11 takes value 1. Rather, this is for the month of February, yes, because the financial year is from April to March. So for month 11, in terms of financial year, it takes value 1 and 0 otherwise. So dummies are there, time variable is there, and your variable of interest which is to be projected or forecasted is here. So first we estimate the trend equation, and the dependent variable is ST. Independent variable for the trend equation is simply the time variable. We have levels, and we want to display the output in the sheet itself. Let's specify somewhere in the bottom, say here, and then click OK. So this is what we get. Our intercept for the trend equation is 19379, and for the time trend, we get the value of 6.2. So 19379 and 6.2. Let's see a slide if that is the case. Right, 19379 and 6.2. So given these estimates, if you have to forecast, say for the month of June 23, that will be simply 19379 plus 6.2 multiplied by 15, because June 2023 in the data series is the 15th month. It starts from April 2022 and April, May, June is 12 plus 3 equal to 15th month. So if you solve this, you will get a projection for the 15th month. And if you want out of the sample, that is for April 2024, your time index will be 25. And if you solve this, you'll get a projection for April 2024. Now let's do it with seasonal dummy. Let's go to the Excel again. This time we have dummy variables in the right hand side of the equation. So let's estimate this regression where dependent variable is st as before, but the independent variables now include dummy 1 to 11. We are not including the trend because there was no trend in the data. However, one can cross-check that as well. And we want to specify a different cell reference so that both results are present in the data set. Let's say we put it here and okay. We are okay if it overrides. All right, so it has overwritten something that was there, which was a text, which we are going to replace later on. Okay, now therefore, what are your estimates? These are your estimates. So intercept is 20871 and last dummy coefficient is minus 2107. Let's see that in the slide. Right. So 20871 and minus 2107 for 11th dummy, and 11th dummy is for the month of February because first dummy is for April. And using these estimates, once again, one can forecast either in sample or out of the sample. So if you wish to focus for in sample period 13th, which is April 2023, only the April dummy will be equal to 1. Rest of the dummies will be 0 value. So April dummy coefficient, which was estimated in the Excel, is minus 60.09. And the intercept is this much. So if we solve this, you'll get the focus value. And likewise, constant remains the same if you have two forecast for next year's April, it will have a similar value because here you are not taking into account the impact of time. So therefore, it's a matter of figuring out with alternate specifications. For illustration, we have not included the trend component. It can be included to check which forecast specification is going to give them better forecast accuracy. So we are now going to check forecast accuracy. And to do that, we are going to use root mean square error. And there are other measures as well. Root mean square error is nothing but the difference between actual and forecast. And that can be positive or negative, which is squared and, added. And that total squared deviations are averaged, and then we take square root because initially it was squared to magnify the impact of large deviations. So using these, let's see whether we have better forecast accuracy with seasonal adjustment or not. We'll do this in the Excel. So the highlighted coefficients will help us forecast. So let's do forecasting with the trend projection method. So what is the forecast? We can do forecast in sample first. So forecast is nothing but what intercept I had with trend. This is the thing. And this does not change for any of the months. So therefore, we are going to freeze it. Then we have the estimate of B, which is the slope coefficient. Again, this doesn't change with any of the months. Now months keep on changing, so that way we have for the first month we get the forecast value of 19385. 19385, and actually it was 21626, right? So this is therefore my forecast value for first month in the sample, and I can therefore find what is the deviation of my forecast from actual. So this is the actual minus the forecast, and this is 2,240 metric ton of deviation, and we will square this. And this now can be replicated for all the 24 months. So we'll drag this down till the month 24. Right. So for 24, the coefficient remains same. However, you have time coefficient is now 24, right? Actual minus forecast is visible here, and your deviation square is here. So what was to be done? You had to sum the deviation squares. That's from R2 to R25 here. And then you have the sum. And then you will have to divide with number of observations were 24, and root mean square error will be square root of this number. So our root mean square error from trend method is 1229.9. So this we can note 1229.9, we'll note it in our results, right? So what is the root mean square error of this method? 1229.9. Now let's go back and do it for the dummy method. So let's go to the Excel again. This time we have to do it in this side of the equation. Here we will forecast with dummy, and forecast with dummy there are 11 dummies. Okay, so the equation is equal to the constant term. So let's go down to the regression table. So intercept plus what is next? Next is my next is next is my next coefficient, right? Which is for D1. D1 is not changing, so it has to be multiplied with D1 value, and keep going, add everything that we have. So same thing applies to all the other coefficient, but before we proceed, let us also freeze this constant term. Okay, so likewise, you will have D2 coefficient into D2 value. So we'll have to do it. So this may take a minute, right? So let's still do it. Okay. So now let's go to D2 coefficient. It is not changing. Multiply it to its D2 value plus we have D3 coefficient, which is also not changing, times D3 value, then goes plus D4 coefficient is here, not changing, into D4 value, almost halfway, then comes D5 coefficient. Of course, one can do shortcuts, but let's understand and do it manually. Little bit. D5 into D5 plus D6 first the coefficient. Let's put it D6 coefficient raised into D6 value. Then comes D7 coefficient into D7 value plus D8 coefficient into D8 value. Then comes D9 coefficient, almost there. into D9 values plus D10 coefficient into D10 values plus last one is D11 coefficient into D11 values. Okay, you're ready to get the value. So what value do you get? So focus value is here, 2811, actual is 21. So let's see the deviation of actual minus forecast. Actual is this minus forecast with dummy method is this, right? So there you can clearly see the deviation is lower this side and square value will obviously be lower. All right. Here you have 7 digits, here you have 6 digits. Now drag and get it for all the months. And then we can find root mean square errors of dummy method for this particular series. And we have it here. So we have the focus value for the month of March. This side deviation is quite low. This is the square deviations. Now it's possible for me to get the sum by n, and root means square error. Sum is the 24 sums, divide by 24, and if you square it, in the sense take the square root, you get only 487. So 487 is my forecast error for this method. So let's compare. 487.5 is my 487.5 is my forecast error. So I must be now deciding which method to use for forecasting. So therefore, what value do you get? 487.5, which is much lesser than 1229 with trend projections. So therefore, in this particular series, seasonal adjustment yields better forecast accuracy, and you will have to now know what was the forecast values. So that's given here in the Excel file. If you see the Excel file, these are your forecast values. And for suppose you have the month of April 24, that is out of sample, how you will get that forecast? You will need to have the inputs ready. So let's see that and close. So for that, you will need to have the 25th month ready, and 25th month would be which month? it would be April, and April is dummy 1, which will be 1, and rest of the dummies will be 0. And with seasonal adjustment method, you have a forecast value of 20811.52 with seasonal adjustment, and that is because there is no trend in this model, and your dummy for the last month, that is March, is not included in the estimation equation. So that way we are getting this forecast equal to 20811, and if you have to look at the figure which is available now for 2024, 25, the first month, 21493 is the actual number, and you forecasted it to be 20811, and that leaves an error. Error is not 0 always. There is some error, of course, but between the two methods, the seasonal dummy method gives the better result. So it is for you to do diagnosis of the series and apply appropriate forecasting model to do the forecast of the series for the next month or a few more months. So this is all as an illustration on using forecast on a monthly time series. We have noticed some sort of seasonality, and the result suggests seasonal adjustment gives better forecast accuracy compared to trend, because there was no trend, and that was suggested by the measure RMSE. And stay tuned for more